Magnetism, EM Spectrum and Waves by Bell Seibert and Miller Janella.
First, we're going to talk about magnetism. Dipoles is an electromagnetic phenomenon which occurs in two ways. An electric dipole deals with separation of the positive and negative electric charges found in any electromagnetic system. Next is magnetic field lines, a visual representation of a magnetic field, showing the direction and strength of the magnetic force at any point in space. Next is the magnetic flux, the number of magnetic field lines passing through a given closed surface. It provides measurement of the total magnetic field that passes through a given surface area. Magnetic domains, a microscopic region within a magnetic material where the magnetic movements of atoms are aligned in the same direction, creating localized areas of strong magnetation. Next is ferromagnetic, a physical phenomenon in which certain materials like iron strongly attract each other. Paramagnetic, a form of magnetism where some materials are weakly attracted by an externally applied magnetic field.
Next is electromagnetism spectrum. The electromagnetic spectrum is the complete range of electromagnetic radiation, which is energy that travels and spreads out as it goes in the form of waves. There are 7 different electromagnetic spectrums, such as the different types of waves. First, radio waves. Longest wavelengths used for broadcasting and communication. Microwaves, shorter than radio waves, used in ovens and radars. Infrared, wavelengths slightly shorter than microwaves associated with heat. Visible light, the only part of the spectrums humans can see, consisting of the colors of the rainbow. Ultraviolet, shorter than visible light, can cause sunburn and is used in some sterilization processes. X-rays, very short wavelengths used in medical imaging and security. Gamma rays, shorter wavelengths and highest energy, produced by radioactive decay and used in some medical treatments.
Next, we are going to talk about 3 commonly asked questions about electromagnetism spectrum. First, what type of visible and non-visible light are present in the electromagnetic spectrum? The electromagnetic spectrum encompasses all types of electromagnetic radiation, including visible light, the colors of the rainbow, and various visible forms like radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. What are the characteristics of the electromagnetic spectrum? Varying wavelengths and frequencies, including radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Last question. How can we use and apply light in our everyday lives? Basic tasks like seeing and reading to more complex applications like medical treatments, communication, and powering technology, with natural and artificial light sources playing crucial roles.
Next, waves. A wave is a disturbance that propagates or travels through a medium or even a vacuum, transferring energy without transferring the medium itself. To measure a wave, you can use the formula as shown above, where lambda is the wavelength, v is the wave speed, and f is the frequency. A transverse wave composed of oscillating electric and magnetic fields that are perpendicular to each other and also perpendicular to the direction of wave propagation.
Next is period versus frequency. Period is the time it takes for one complete cycle or oscillation to occur, measured in seconds. For example, if a wave completes one cycle every 0.5 seconds, its period is 0.5 seconds. Next is the frequency. Is the number of occurrences of repeating event per unit of time, measured in hertz, which is cycles per second. For example, if a wave completes 2 cycles in 1 second, its frequency is 2 hertz. The relationship between period and frequency is they are inversely proportional, meaning that as one increases, the other decreases. If you look to the picture to the right, it shows exactly that.
Thank you for watching.